Hi guys, so in this video we're going to be doing vertical projectile problems, so you're more than welcome to pause the video and attempt the problems by yourself. So this is question 3 and it states ball A is projected vertically upwards from the ground near a tall building with a speed of 30 meters per second. Ignore the effects of air friction. Now explain. 3.1 states explain the term projectile. So projectile as defined is when an object that is launched with the initial velocity moves under the influence of what? Of gravity. That's how you can define vertical projectile, right? Now let's draw the scenario so that we can see. They say it's projected vertically upwards from the ground near a tall building. So from here on we can see this is the scenario itself. We're gonna draw it, but then it's fine, we can use this one. So now let's begin with the problems. Now, which direction are we going to be taking as positive? So up, it's going to be positive. So upwards, it's going to be positive. That's the one that we are going to be taking. So now they say calculate the total time that the ball will be in the air. So what are we given? Right. So let's write our data, meaning the amount of data that we were given in order to solve this problem. We were told that the v initial is equals to 30 meters per second, and we know that the acceleration is equals to 9.8 meters per second. And what else do we know? Those are the two things that we know. Now, what can we use in order to solve this problem, right? What can we use? Remember, we're not going to use this 50 because it's in the second question, right? So what we can use is this. Here's one thing, the VF. The VF is what? It's 0. Now why? Remember they said ball 8 projected vertically upwards from the ground near a tall building with a speed of 30. Now this ball, it's thrown up, it's projected upwards, and as said, it will reach its maximum height whereby the VF will be 0. Now we don't know where is that point, but then we do know that it will reach that point whereby the V initial is what? The VF is what? Is 0. So that's how you can use it. You just have to know and understand that, okay, that's how that is what's going to happen. So now which formula are we going to use? The VF is equals to V initial plus the A change in T. Now this is the one that we're going to use. Since up is positive, we know that the acceleration is going to be negative. They said the total time, of which we're looking for this, and then now since it's going up, the data is going to be positive, and then now the VF is 0, and then now we're going to solve it, and we should get what? We should get 3.06 seconds, because you know it's going to be 30 is equals to negative 9.8 change in T, divide both sides, you should get 3.06 seconds. So since they said what is the total distance traveled by the ball, the total distance, the total time, by the way, is going to be 6.12. Why? Here's why. Now remember, what goes up needs to come down. So this ball itself, it went up and it's gonna fall down. So they projected it up with the v initial of 30 meters per second. It's gonna reach the top and then it's gonna come down. So that's why I multiplied it by 2. Basically, if I'm to draw, I'm to describe the its motion with the graph. It's just going to be like this, a parabola. That's all there is to the first question of 3.2, because there's nothing much I can add and say. So yeah, that's all to the first one. So the total time, it's going to be, for this one, it's going to be 6.12, right, seconds. Good. Then afterwards, let's look at 3.2, shall we? Good. Now 3.2 itself, it states the distance, calculate the distance traveled by the ball A during the last second of its fall. So now, if I was to draw this scenario, let me draw this scenario. So this ball is projected up. Now it's going up. Now they want to know during the last second what was the distance traveled. Now maybe let me use a different color for this side. Maybe they want the distance at this point that it traveled before it fell or touched the ground. Right? Now, how are we going to solve it? Now, remember, as I said, up is positive in this case. Now, in order to solve this one, what do we know? We know what? We know that the V initial still the same. V initial it's 30 meters per second. And the VF, you are more than welcome to say it's negative 30 meters per second, because basically if it went up by 30 meters per second, it's gonna come back down by the negative 30 meters per second, because it comes. That's why the reason why for the negative, it comes back in an opposite direction, which is what? Which is down, right? So we know this, and then A is what? It's 9.8 meters per second. Now I can't use this time because it's for the total distance the ball the ball traveled. So what can I use? Okay, so for this case, what we can do is to use the formula of this. Changing y, I will explain why. Changing t plus 1 over 2 changing t squared, right? To find the total distance, right? Good. Now, in order to find it, what am I going to do, right? Firstly, I'm going to substitute. I'm going to use this 6.12. There's a reason why, because I'm going to use it and then subtract the distance, the other distance from it. Now, here's how. So since initial it's 30, it's going to be 30 times. This is for the first one. Let's fill in the first one, which is this one. 6.12 plus 1 over 2, 9.8. I forgot the A here, important, and then the change in T, which is 6.12 squared. Now, in order to find the distance the ball traveled during the last second of its fall, this is the total distance it traveled. Now I'm going to subtract that total distance by the last second. Now, when they said the last second, remember that it is 1, 2, 3, 4 seconds, 5 seconds, 6 seconds, right? Now they said the last second, so this means they want the 5. This is the second that they mean. So they want this. Meaning, I'm going to say minus the V initial, which is what? Which is going to be 30. Which is going to be 30. And 5.12. Remember that since up is positive, 5.12. Remember that they said the last second. So basically before it hits the ground by 6.12, meaning that last second it's 5.12, right? Alright, so let's see, it's going to be plus 1 over 2, negative 9.8, and 5.12 squared. Now, changing y, basically, it's going to be what? After subtracting those two, I get negative 25.076. Therefore, distance was 25.08 meters. Good. So this is how you're going to answer it. Right? So let me give you a recap on this question of on 3.2.2. Now, here's what happened. Now, remember the question stated the distance traveled by the ball A during the last second. Now, the last second is 1 before it hits the ground by 6.12. So the last second is what? It's 5.12. Now, after I add that 1 second, it becomes 6.12. So that is the tricky part about this question. It's because you have to understand the word play in this question. Like in the first problem, you have to understand that, okay, this ball is going to come down, right? So you have to know that if you throw a ball up, it will come down. Good. All right, now let's do 3.2. Right, I'll save this one here, say 25.08. Let's do 3.12 so that we can be done. Here we're done. Good. Okay, now 3.3. Now they say 2 seconds after ball A is projected up, ball B is projected vertically upwards from the ground of the same building. The roof, the building is 50 meters above the ground. Both balls A and B reach the ground at the same time. Refer to the diagram below. Ignore the effects of air friction. Now, since they reach the bottom at the ground at the same time, this means that they have what? They don't have the same time. You could assume that they have the same time, but here's the one thing. They said what? 2 seconds later. So from the total distance that A traveled, you can subtract 2, of which this means this one traveled 4.12 seconds, right? That's the total time of the second ball. Now, before I even make my own suggestions, let's firstly see what the question is. Now they say calculate the speed with which ball B was projected upwards from the roof. So we want the V initial. So the V initial, we are looking for it. So the V initial is unknown. What do we have? Let me write this as a question mark. So what do we have? We have A, which is 9.8 meters per second. Now what else do we have, or what else do we know? We know that the change in T is 4.12. Now for those who are wondering, I said since the total distance for ball A was 6.12, for this ball, since they said they projected it up by 2 seconds later, you're gonna have to just subtract 2, of which you're gonna get 4.12. So that's all that you had to do. Right? Now from there on, what else do I have? I have the total displacement, or the height of the building, which is changing y, which is 50 meters, right? So from there on, you're good. We can now find our the v initial, right? So we're going to use what? We're going to use this formula, change in y, this equation of motion, formula or equation, v change in t plus 1 over 2a change in t squared, right? Good. Now the change in y, since up is positive, it's going to be negative 50, right? Negative 50. The reason why is, okay, the reason why for the negative, let me show you a little bit of a trick. You see this, let's assume that this is a Cartesian plane, right? Now this ball B is projected from this point. Now anything below ball B is negative. Now we said up is positive. Now that's why 50 is negative. But if we said down is positive, it was going to be a positive 50, right? So yeah, hope that is clear. Now the V initial, since this is the one that we're looking for, right. Now it's going to be 9.8 and 4.12 squared, right? Now we're going to find the V initial, of which we're going to simplify this, and in the end we should find it as 8.05 meters per second. Then this is the speed at which this ball was projected, right? 8.05 meters per second. Perfect, right? Good. Now let's start to look into 3.4. No? Good. Right, now 3.4, it states sketch the velocity time graph for the motion of both balls A and B on the same set of axes. Clearly label the graphs for balls A and B respectively. Indicate the following on the graphs. Okay. Time taken by both balls A and B to reach the ground. Time taken by ball A to reach its maximum height. Alright, so we're basically going to be drawing the velocity time graph, which it's the straight line. I explained why in the introduction video. If you haven't seen it, please go watch it, because it's the first video that you have to watch before you start to attempt these problems. Alright, now, good. Okay, now since we have done this, what we can do is to first start with ball A, right? So ball A, what was its V initial? Ball A, its V initial, it was 30. Now this graph is for up is positive, right? Now if down is positive, you're going to do it the opposite way, right? Good. So from there on, they said what? Time taken by the ball to reach the ground. Now the time it took for the ball to reach the ground, both of them, it was what? 6.12, right? Now after this, what else should I? What is the V initial of ball B? Of which ball B? It was. Let me use a different marker because I can see, which is 30. Now for ball B, it was what? It was 8, right? Ball B, it was 8.05 meters per second. Please also indicate on the side that this is the velocity time graph, right? VMS, T here, seconds, because it's important so that they can know what you're doing. And then after this, what else are we missing? We are missing the time. So they said it started 2 seconds later, so you can just put the 2 seconds here. Now you can start to draw your graph. And they said what? The time taken for it to reach its maximum height. Now you don't need to do much to find that time. You just have to divide this by 2. That's the maximum height, right? Since this one, it was projected from the ground, it went up, and it came down. So there's nothing special about this ball A, I mean. So it was 0.06, right? Now we can start to sketch our graph. Now mine won't be pretty at all, but then I'll try to make it as beautiful as possible. Now this is ball A coming down, and it gets here, right? And we can start to do this. Now let's look at ball B. Now it started 2 seconds later, so I'll just sketch this, or let me do this, and alright, 2 seconds later, that's when ball B started to ball B was projected, right? So good, good, and bingo, right? Now mine are not straight, but it should look similar to this. And this is ball B, this is ball A. Now for someone who's asking, they didn't ask for the VF, right? But then, like I said in the beginning, the VF of ball A would just be 30. Right? It would just be negative 30 because it went up like if it went up by if it was projected by 30 meters per second, it will come down by negative 30 meters per second. The law of conservation of energy. Energy cannot be destroyed nor created. It can only be conserved. Good. So just like that, we are done with question 3. And if you have any questions, please leave them in the comment and I'll reply to you as quick as possible. And if you want to inquire about my private tutoring, you are more than welcome to email me. The email is in the description. And guys, I'll see you in the next one.